Hi, everyone, and welcome to the AWS Public Sector Summit. A few housekeeping items before we begin. The main door at the back that you came into is the emergency exit. We do ask that you all please silence your cell phones for the duration of the session, including that video. And please do download our mobile app. You'll be able to give a survey on this session, and we do take that feedback really seriously, and we act on it. So really appreciate your feedback there. So without further ado, wanted to welcome you to this particular session entitled Innovating Humanitarian Assistance and Disaster Response with AI and ML. So we have an amazing panel of organizations who are leveraging AI and ML to do some incredible things, improving how we can predict, prevent, and plan for and respond to natural disasters. And they're here to share their experiences and hopefully help you walk away with some tips and tricks as well. So I'd like to introduce our panelists today. First, at the end, we've got Maggie Carter, Principal for Disaster Response here at AWS Public Sector. She's our moderator for the day. And then we've got Zach Verdana, who is our Geospatial Information Officer, GIO, at the Nature Conservancy. And then we've got Tony Frazier, the EVP of Global Field Operations at Maxar Technologies. And finally, Sajid was before, Sajid Joseph, CIO of the American Red Cross. So, thank you.
Thank you, Layla. I'm excited to be moderating this panel today. It's clearly a passion of mine. This is my job. But I'm really excited to hear from our panelists who are really at the cutting edge in this space of using ML for disaster response, whether it's on the preparedness side or the response side. And, you know, there's a diverse, when organizations are responding to a disaster, there's so many different use cases that organizations are responding to, whether it's, the Red Cross and it's, trying to better predict blood levels, or whether it's the Nature Conservancy and working to, really preserve our coastal lines, or really Maxar and how they're enabling organizations to better leverage, data that's out there using ML in this space. So really, too, it's fascinating to see how ML has really transitioned, and it's not big tech companies aren't the only ones that are using AI and ML these days. It's really powerful how cloud computing and algorithms and open data have really allowed organizations to embrace ML, and really experiment with it, whether it's a medium-sized organization, a startup, or a small NGO. And so I'm excited to be talking to you guys today about the power of ML for disaster preparedness and response. So I'd like to start with a question for each one of you. Just really want to better understand, your organization, and Zach, we'll start with you. What use case you have at the Nature Conservancy?
Well, thanks, Maggie, and everyone for showing up late in the day between us and happy hour. I think we'll keep your attention, hopefully. A Geospatial Information Officer at the Nature Conservancy. I've been with the organization about 19 years. If you don't know the Nature Conservancy, our mission is to conserve the lands and waters on which all life depends. We have a long history of land and water protection. We've been around since 1950, have conserved over 1 million acres in the United States, and basically started the land trust movement. I'm a conservation planner at heart and in my profession before becoming GIO. The Conservancy has done a lot of conservation planning throughout the decades since 1950 when we were founded. My background is in Geographic Information Systems, or GIS. A lot of our initial work was just on real estate, buying and selling land, parcel-based mapping. We then went to a very regional approach, eco-regional or regional planning, trying to find biodiversity hotspots, and then came to realize through those efforts, we still were not doing enough. So we started to hire coastal engineers, economists, to understand how to restore habitats. And that's where the nexus point with our humanitarian friends at the Red Cross and other organizations have come into play. restoring natural systems for nature and people. So we made a concerted effort to look at the humanitarian cycle of disaster preparedness, response, and recovery. We really focus on the preparedness and the recovery phases of it, and through a use case that we have in Indonesia, where we looked at using machine learning to train an algorithm from the Twitter streaming API to map flood risk in Java. Being able to have real-time or near real-time flood event detection from the Twitter to the social media dashboard from our partners at Flood Tags in The Hague in the Netherlands, to be able to map flood risk for city planning. That, coupled with our mangrove restoration work, if you're familiar with Esri and the ArcGIS platform, they had us, we worked with them to build an ArcPro mangrove restoration or simulation model, so we could understand the relationship of where consistently in the city of Semarang, Java, on central Java, where places were flooding, with where we could restore mangroves with this simulation model, mangrove model. Didn't have any slides or pretty maps and stuff, but I'll show you that later. If you go to preparecenter.org/RCC, it's part of the Resilient Coastal Cities program that the Global Disaster Preparedness Center of the American Red Cross is leading, for which we are a partner. So I can say more about that, but I think I'll pass it on to my colleagues and we'll get back to that.
Sure. So, Jeet, if you can tell us, I know you've got several use cases, and I don't know if everyone knows the Red Cross, and I'm sure people know the American Red Cross, but today you're going to talk about the work that you're doing, specifically in blood supply, which is fascinating.
Right.
Can you share a little bit more about that use case?
Sure. So most people know of the Red Cross as a disaster relief organization, and we do that. But in addition to that, we do a lot of other things. One of the biggest things which we do for for United States is provide blood service. So we provide about 40% of the nation's blood supply, and to do that, we hold about 60,000 blood drives throughout the year. So the first ML use case which we looked at is, for all these 60,000 blood drives, we don't have an accurate way of predicting how many people will show up, how many people just walk in for blood appointments, because not everybody makes appointments in advance, so some people walk in. And that's a problem we want to figure out, because if we send less people less phlebotomists, people who collect blood, to a blood drive, then you would have long lines, and that's a bad customer experience. If you send more people, then you have a cost problem, because you're spending more money for a blood drive where you'll expect less people. So our first ML use case was trying to do a predictive model of how many people will show up for a blood drive. And that is one thing which we use to predict future blood drives. And this is based on each individual blood drive would be in a location, different time, and different date, and having that kind of model which predicts the show rate for people. Now, based on that, we start being more prescriptive, saying, okay, now that we know how many people will show up, can we predict how many people should we send to the drive for collecting blood, and what is the optimal duration of the drive? So we start getting more prescriptive with respect to that kind of predictive data. So that's how we started off with our journey, and then we started looking at other things like, now that we have done a sense of predicting how many people show up, can we predict the flow of donors throughout the day? Now, we have not yet cracked it. We're in the early stages of that, but we're trying to kind of mature that whole life cycle and go from next model to others. We're also looking at other disaster services type models as well, but we'll talk about more as the day as the session progresses.
Thank you, Sajid. So Tony, now to you with Maxar Technologies, and I'm not sure, most people might know Digital Globe. Can you tell a little bit more
I'll
about?
help bridge the gap.
Yeah, okay, thank you. And then how you at Maxar or Digital Globe are enabling organizations in their efforts.
Yeah, thanks Maggie. So as Maggie mentioned, I'm with Maxar Technologies. We were formed about 2 years ago through the combination of Digital Globe and MDA. And so we rebranded the corporate parent. The first year and a half, we operated under 4 different brands. So people are familiar with Digital Globe as our imagery company, SSL is our space infrastructure, manufacturer, Radiant Solutions, which is a group I led at the company, which was our geospatial analytics business, and then MDA is a Canadian defense contractor. So in the early part of the year, we combined. our operating units, to create Maxar. And really one of the reasons we did that was we felt like there were opportunities for us to add value across what we call the Earth intelligence value chain. And so when you think about the problem, and whenever there's a need to address a trending event, like a humanitarian assistance disaster response event, you need to be able to collect data, enrich it, analyze it, and get it in the hands of different users. And the type of capabilities we deliver across Maxar, that's what we enable. And so when I think about what we're doing and applying machine learning to this problem, I think about where we were yesterday and where we are today, and then ultimately where we need to go tomorrow. In terms of where we were, I joined the company in 2010, and at the time we were just starting to get data exposed to users online, through online mapping platforms in the cloud. And one of the innovations that occurred at that time was, and I think about the Haiti earthquake as an example, where that was the first event where crisis mapping really took hold. So the Humanitarian OpenStreetMap team was able to, in several days, do something that would have taken weeks or months before, by getting lots of users to rally around imagery and digitize features before and after, to be able to then inform response. As we kind of evolved over time, we created some programs around that. And so at Maxar, we now have an open data program where we make imagery available to the public for major events. So we look at events that would affect north of 100,000 people, as well as those that are sudden onset events, things like earthquakes, tornadoes, wildfires, floods, those types of things. And so we've done 37 of those activations over the last few years. And what we've seen over time is that while crowds can quickly do damage assessments and mapping, you need to bring automation to the fore to compress the timelines to be operationally relevant. And so a lot of our early experimentation with AI machine learning to this problem was doing some of the things that that crowds could do, but applied with machine learning. And so one example I'll give, just to set the context, we had an event last year, Hurricane Michael affected the Gulf region. Mexico Beach was one of the areas that had massive devastation. We were able to, in very short order, make imagery available, so pre-event imagery that was collected from our satellites. We combined that with post-event imagery that was collected through an aerial platform that was made available through open systems with NOAA. And we did automation, so we ran a machine learning algorithm to be able to digitize every building in that region, so over 7,000 buildings, and then had crowds go through and do damage assessments. And so within 3 hours, we were able to quickly be able to see, of the 7,000 buildings, how many were completely destroyed, partially destroyed, and intact. And so those are the types of things that then get it in the hands of operators under really quick timelines. And so a lot of our efforts have been focused on how do we support a more generalized set of problems through advancing machine learning, and then applying that. The world's very large and complex and geographically diverse, and so how do you make sure that those algorithms work in the time that matters?
What is your feedback loop? I'm just curious, in terms of the operators and compressing that timeline and being user-friendly.
So I'd say there's two feedback loops. One is some of the tools that we built to allow you to run an algorithm, inference against imagery, and then use tools to validate the output. So we had a tool called TomNod, and we've now deployed that through a crowdsourcing service called GeoHive, where whenever we inference a set of outputs, we then have users go back and validate those. And so that's one form of a feedback loop. Now where it needs to get over time is, as we deliver that data to the edge, getting users in the field to provide another form of ground truth. I think that's a massive unlock.
Thank you. So Zach, back to you. I heard you talk about the Nature Conservancy and a regional planning approach and a lot of collaboration in the field. So with that in mind, what are some of the challenges that you have at the Nature Conservancy? What have you encountered while embracing AI and ML, whether it's at, say, the headquarters level or regionally or in the field?
Well, I think it's sort of a re-education process of talking about ML as a training set and as a management tool. So the example in Indonesia, we had to create a Bahasa or Indonesian language training set to grab keywords from Twitter to turn them into flood risk maps. And so this particular algorithm can be retrained, and talking to our staff in Indonesia of the purpose of creating a keyword training set for a machine learning algorithm was completely unknown to them. And so if you talk about flooding and flood risk, in sort of the colloquial sense, you get a series of keywords. Once you say machine learning and you say this is going to go into an algorithm, there's a lot less words that get spoken. And so it's sort of a re-education of how you take a training set and educate people to make that training set robust. And so this flood risk algorithm that we've created that can be retrained is an incredible opportunity where we have the foreign language translation, we have an education process of honing those keywords so that the mapping becomes more specific. And that's important because whether you call it citizen science or another term, the city of Semarang on Java are saying, well, why would I use this flood information for mapping flood risk? Why wouldn't I use more authoritative data sources? Well, this is a streaming near live flood mapping situation that they can catalog over time that gets refined over time. So in a city planning and recovery sense of the fact that the sediment is completely going out into the ocean and the city is sinking, this is a critical issue that they should be addressing, and we're helping them address with our friends at the Red Cross. And it's all about educating on how you talk about flooding that translates into machine learning algorithms.
And so with that in mind, I'm jumping ahead, but how are you then looking at scaling, scaling this work outside of Indonesia? Whether it's, to other markets, or are you looking at using this model for other use cases?
Yeah, so we have hundreds of preserves in the U.S., for example, and we have amazing folks going out and doing monitoring and data collection all the time. If they were thinking about how to monitor and collect data to leverage and scale something like machine learning, then their monitoring efforts would probably be different. And so again, it's sort of an education process of how does the Nature Conservancy, with the lands that we own, how do we know that we're being successful in increasing biodiversity or ecosystem health through monitoring efforts? So the leveraging and scaling to all of our field programs who are out doing stewardship or just exposing issues like flooding, the way that data is monitored and collected is a whole different sort of mindset, knowing that it can go into a machine learning algorithm to then be leveraged and scaled.
Thank you. So Sajid, transitioning to you with the Red Cross and your use cases around predicting blood supply, there's a lot of challenges in that space, whether it's having to do with HIPAA compliance or other. How are you tackling these challenges when you're pulling together an ML model?
Right. So incidentally, we don't collect HIPAA information,
Right.
so we're not. But we are regulated by the FDA, and we've been particularly cognizant in making sure that the type of use cases we are looking at are not dealing with sensitive data and things like that. But data is really the biggest challenge which we have faced, right? And this is probably the challenge for any ML type use case across any organization. So some use cases, you might have the right amount of data, which gives the right signal, and you can solve the use case using that. In some cases, you don't have the right signal, and hence that use case cannot be solved at that point. And then what we try to figure out is, can we get additional data which helps us in influencing that problem? So for example, in some cases, we may have programs which we'll put in place to collect additional data so that maybe we can't solve the problem now, but we can solve the problem a few years later when we have additional data. But in our overall life cycle, incidentally, we didn't have a lot of change management problems. It's been mostly around, as we look at different use cases, do we have data type issues?
Right.
From a change management perspective, the way we have tried to avoid those problems is that we've kind of integrated ML inside the business process. So if a business process conducts steps A, B, and C, and step B is where we're trying to build ML in the middle, we'll make sure it's seamless to the end users on how ML is being applied. So that becomes a lot more, there's really not a lot of change management to be done, and it becomes a lot more easier for the end users to use the tool.
Right. And what sort of, it's the middle level, what have you done in order to influence or educate about the importance of, data standards or data collection, whether it's at the end user or somewhere in the middle?
So right now we've been trying to focus more on which use cases can we actually solve.
Okay.
And we've started doing some work in trying to make sure that we are collecting the right amount of data for future opportunities, but we are still early stages in that because those kind of things require a more broader adoption across the organization, a lot of storytelling, a lot of selling the concept, and we're just not there yet.
So with the storytelling, is that how you're getting internal buy-in at the leadership level and then at the, say, practitioner level?
Right. So what we start off with is the business outcome which we are trying to achieve. So we'll look at, okay, we feel like there's a hypothesis that we can achieve this kind of business outcome by doing this ML use case. We'll test out the outcome, and then have conversations at the leadership level and at the team level as well, saying, okay, this is what we think, this is what the outcome could be, let's experiment, let's test it out. We'll give a small time period, maybe a couple of months to test it out and see if in a small sandbox it's working. And if it's working, then people get excited around it, right? So that means we can actually influence change with users who are actually using this capability, and which means they get positive business outcomes. And that's the process we've been using, more the fail-fast approach, right? Let's test quickly if it's working, and if it's working, then we'll try to scale the operation so that we can deploy it nationwide for use.
Great. So Tony, can you dive deeper on your ML algorithm that Maxar kind of enables organizations to use, and how has that been used in preparedness situations, not necessarily in response?
Sure, thanks. So we've approached our journey in ML in layers, I guess I would call it. So as I mentioned earlier, the first stage was getting the data in the cloud. So we moved 100 petabytes of our imagery into the cloud. We're adding 80 terabytes of new data a day. We know with our new constellation, we're just going to continue down that path. And building a bit, Sajid, on the use case you referenced, we don't know what all the questions are that can be answered with our data. And so part of our approach has been to try and democratize access to the data, and also facilitate research that would allow us to start to extract information from that the data scale. And so some of the algorithms have been built by us, some have been built by our partners, some have been done by the open research community. And so one example that was really interesting I saw was Facebook. They built an algorithm to do population density mapping for a large region in Africa, and they open sourced the data set that was generated from processing, I want to say over 50 million square kilometers of landmass that was analyzed using our imagery, and that was used to support both planning around next-gen communications, but also looking at health scenarios. The Gates Foundation has done similar methods to figure out where to direct polio medicine. So those are use cases that happened organically because we made the data available in the cloud, and we equipped our customers with the tools to start to experiment against it. Some of the things that we've been working towards is that with satellite imagery, particularly the imagery we collect, which is very high resolution, it has a lot of details about what's on the ground. So both what the features are on the ground, so the roads, the buildings, the points of interest, moving features like different types of vehicles, planes, trains, automobiles. And so one of the things we've been working towards is facilitating research where we can mature the state of the art in terms of what's out in the open. And so a lot of the innovation that's happened with computer vision, with photos that you would collect with your cell phone, it's a lot of different methods, for how you would extract features from satellite imagery. And so ImageNet is recognized as the kind of predominant research data source for computer vision for ground photos. We started a collaboration several years ago with InQtel Cosmic Works, one of the labs there, called SpaceNet, and the goal there was to take certain foundational mapping features and see what we can do to improve the state of the art there. And so we've run four challenges. We've looked at in different geographic areas how we could improve the quality of public open source algorithms for extracting buildings and roads. That inspired work that IARPA did on a similar challenge called Functional Map of the World, where they looked at dozens of mapping features. NGA and Defense Innovation Unit did a similar challenge that we helped support with machine learning training data to categorize dozens of moving objects. And so as we created those algorithms, I think through the SpaceNet effort, there's 18 open source algorithms that are available for different features. We've then been able to use that to at least understand, using our imagery with these open source algorithms, what type of quality results we could generate. And with that information, again, that allows you to better characterize what's happening on the ground, what's changed, which gives operators insight as to where to focus their efforts.
You brought up something that I actually wanted then direct at Zach. So what we've heard from a lot of our customers is, that they lack, say, data scientists or experts in ML, right? And so it's one of the biggest blockers, right? So how have you tackled this at the Nature Conservancy, and same with you at Saji? And then for you, Tony, what would you recommend kind of as an organization that works with, the Red Crosses of the world? So I would start here.
Well, I think it starts with priority and executive management and understanding that data and technology are going to be a real driver of conservation in the future, now and in the future. We have a small and growing body of data scientists, and we have a couple of other use cases that is helping us understand the kinds of leveraging and scaling and conservation that we can do. We have a Mapping Ocean Wealth program that's looking at images on Flickr, identifying coral reefs and then driving the number of images when people go on vacation as into an economic model that shows the value of coral reefs globally, and trying to do that more real time. So if there's a bleaching event, you can see that tourism goes down, and it's sort of a lose-lose there in conservation and tourism. So we're coupling with different management objectives like tourism and conservation, but ultimately it's understanding from executive management the priority of technology, developing use cases to show what we can do, and then ultimately creating capacity pathways. So if we have a great example in Mapping Ocean Wealth or in Indonesia, and people say, that's really great, how do I do that? We either the capacity pathway through contracting or building internally capacity through some geospatial data scientists that we have on board, and ultimately it's training. Yep. How do we train and have training opportunities to then really go to scale with the technology?
And you're also in the process of exploring SageMaker for one of your use cases that we haven't talked about. How do you see, does SageMaker kind of democratize ML for organizations?
Yeah, I mean, I think it's really a matter of sort of exploring the different APIs that are out there on the cloud, like SageMaker, and working so another capacity pathway would be working with the Envision team to understand your guys' expertise in less of a hackathon situation and more of a, can you join our project team for 6 to 8 weeks in a certain number of hours, expose us to SageMaker and other ML APIs that are going to help us sort of move the needle in conservation. And through that, that's a form of training. So it's not just contracting or a weekend, it's actually joining the team for a while.
So it's that training, enablement. Saji?
So our journey has been a little different, and most people tend to look at ML as a black box, right? It's all very complicated, and you need heavy data scientists. We've kind of broken up our data science journey into like 4 pieces. So the first thing is problem identification, and we spend a lot of time there. So what problem are we trying to solve? What kind of outcomes are we expecting if that problem gets solved? Then is the data prep side of things. Do we have the right data? Where is the right data? Is it clean? Is it available? The third piece is where the ML comes in. Once we have all of this done, now we'll get our data scientists to be able to play around with that data to be able to create the model. And then the fourth piece is more of the data engineering, productionizing of that concept, creating edge computing to make sure that whatever model we have put in place is available in hands of end users. So if you look at this, right, three of these pieces don't really need machine learning specialists. And that's the way we've kind of dealt with is that the first two pieces, which is problem identification and data prep, is where most of the time is spent. And we have our data scientists focusing on the ML piece, which is the third piece, and then we'll have software engineers and data engineers focusing on the last piece. So that's how we've kind of optimized our ML journey so that we can have more throughput with respect to more opportunities being identified with the amount of ML resources, because ML resources are scarce, right, in the market. So that's how we've kind of looked at optimizing it.
Tony, what have you seen, say, across the nonprofit or NGO community specifically, or maybe public sector broadly, let's say?
Yeah, I mean, just maybe to speak about public sector more broadly, one of the challenges we see is that there's a scarcity of talent that understands data science and machine learning. There's also when you look at our industry specifically, satellite imagery and geospatial data, that's also a fairly small community. And so you look at the intersection of those two, and it's a very, very small community. So in order to scale that and go broader, we have to democratize. So a lot of what I see as a path forward there, and having been part of the workshop yesterday on AI machine learning, is we need to get capabilities that we're all very familiar with in our world integrated into this broader ecosystem of tools that are touching tons of users. I saw Teresa made the comment, 10,000 users on SageMaker. I mean, that's stunning in terms of the level of adoption. And so some of the things that we're exploring is we're making the imagery more accessible to that user base. We're making the machine learning training data more accessible. So we've partnered with Amazon as part of the open data program to make the SpaceNet data available, as well as other labeled training data sets. But then also, we've built a number of tools that bridge the gap between remote sensing data and running different algorithms using these various machine learning frameworks. So we've created some free software development tools. DeepCore is one, where part of an action that we're taking as a team is how do we get those tools better integrated into the SageMaker ecosystem, and then also drive outreach, because I'm convinced I have over 100 openings right now I'm trying to fill for roles just with my federal customers, and it's very hard to find talent. We got to grow it from within. And so I thought the last session on the education panel was really interesting. I think we have to create more opportunities to expose the content, the tools, the methods, to people early, in their educational career, so that they develop passion for it, and then we can create opportunities for them to grow.
Absolutely. Yeah,
can I just, the last two comments are great. It makes sort of do what you're good at.
Yep.
And so the black box and it's out there is a very scary notion, and there's a big leap to it. But including it into a stepwise framework of what our organizations are already good at. Right. There are 1,300 GIS and map makers in the Nature Conservancy, and so leveraging all of the scripting and programming and application work that they do, and then say, well, let's enhance it with this algorithm, is not a big leap. But taking it to this black box and it's out there, it seems like it is. So just do what you're good at and enhance it.
Right.
Okay, so we're going to do one more question, and then I'm going to open it up to Q&A. And this is for each one of you, and we're going to start with Sajid this time because you're the middle child. So sorry about that. I'm a middle child, so I feel your pain. Okay. If you can predict what AI ML will do for disaster preparedness and response in the next 5 years, what would it be?
So we can't stop disasters, right? And no matter what technology comes in place, we won't be able to stop disasters. but we can help save lives. And that's my hope where ML and AI can help the most, is that once there's a disaster, or we know that there's a disaster, can we reduce the amount of lives which are lost, or injuries which have happened, to the least amount possible? And that's where ML and AI can help with more preparedness tools, more advanced warnings, and those kind of things. And in some cases, we can actually reduce the impact of the disaster itself. So there's a lot of ML research being done in wildfires, in the wildfire area, to kind of make sure that the impact of wildfire is reduced. There's a lot of research being done with flooding data. So there are sensors which have been put into all these rivers, which will help in making automated ML models to figure out flooding of rivers. So a world 5 years later is going to be a world, hopefully, where we won't lose lives because of disasters, and we can actually reduce the amount of impact to disasters as well. And then there's a third component, which is, now that a disaster has occurred, how fast can we deploy resources and be able to solve the post-disaster relief operation? And how quickly can we do assessment based on things which Tony was talking about, and be able to figure out damage, make sure we are helping people, and combining all of the data points to be able to help people in need. So that's where I feel the world's going to be 5 years later. There's just a huge amount of opportunity in how ML could be used in the disaster response space.
We're going to go to Tony.
So one of the areas I'm really excited about is what can be done at the edge.
Yeah.
So the work's being done with the Snowball Edge device, and being able to pre-provision that with information about the before state, and then if you could have through real-time communications, be able to downlink new data, do processing at the edge, equip those operators with a kind of a real-time living map of what's on the ground. I think those are the areas that ultimately get us closer to the mission. And so seeing, and all the pieces are there. It's about getting the communication infrastructure to be able to get new information down to users, get the algorithms to be generalized, so they deliver good enough results on short timelines, and then all the applications you could run on that type of device, I think would really make a huge difference in terms of the mission.
Absolutely. We've heard that from multiple customers. We'll talk. So over to you, Zach.
Yeah, I would say sort of a two-part answer. One is just the humanitarian cycle of preparedness, response, and recovery. In the next 5 years, I would hope that the Nature Conservancy and humanitarian organizations like the Red Cross and others really come together and see that nature protection is part of the humanitarian cycle of preparing for disasters. Intact ecosystems, there's plenty of literature out there that shows intact ecosystems, at least on the coast, do their best to buffer against some storms, not all superstorms, but those studies are out there. And then in recovery, like I say, we have coastal engineers. We're thinking a lot about how we restore and bring back ecosystem health. So this intertwined nature of humanitarian and conservation work needs to go hand in hand. From the second part is just the conservation world. I really think we need a data and technology revolution in conservation. What we do really well at is buy land, protect, negotiate, work with a whole array of partners and management objectives to meet our conservation goals. But measuring our impact, conservation impact, I mean, is something that I think the ML and AI world can really help with. We have, like I say, over 1 million acres in the US on protected lands, tens of millions of acres that we've helped protect internationally. Many of these protected lands are not in good health. You think, well, they've been protected, there's a big fence around them. Well, there's poaching, there's invasive species, there's all sorts of threats to protected lands that we have. Can you imagine if we can have sort of the technology facilitate a management scheme where we're tracking almost in real time when, say, deforestation happens right outside the park that then floods the park because there's no trees to capture the sediment, that we could change our management, the way we manage our lands, knowing how effective we are in our conservation impact. I think that's something that through dashboards and artificial intelligence, we should be able to get to, so we can better manage our lands.
Has the Nature Conservancy looked at doing any sort of analysis? If you look at Haiti and the Dominican Republic, when they're impacted, why Haiti, it's much more devastating to Haiti than, say, the Dominican, and the difference between, say, if say, Conservancy was a part of that, if you look at their geography, meaning trees, deforestation in Haiti.
Yeah, it's terrain, and it's a it's a long legacy, unfortunately.
Might be a
of
project for us to
deforestation.
talk about.
Yeah.
Sorry, I was just curious. Took us on a tangent then. Okay, great.
We could say more, but let's not.
Yeah, we'll go there. We'll talk about that later. Okay, so now I'm going to open it up to Q&A from the audience. If you have a question, please say who you are and where you're from before you ask your question. You can either raise your hand, and we've got a mic. Yep, right here.
Afternoon. Andre Kearns, Maxar. My question was for Sajid. I was just curious, do you have any measurable outcomes that you've been collecting in terms of the effectiveness of applying ML to enable your blood drive planning?
So we wouldn't deploy a product or a use case if we don't think it'll have the right outcome. So that's the first thing we do as a part of an assessment before we even deploy the model. And then once the model is deployed, then its comparison exists against what would have happened without the model and what's happening with the model. So for example, the first model which we worked on, the path which we take for most of these projects is, okay, now that we feel it's successful, we feel on paper that the model works, but let's actually put it in a pilot location. So we'll actually deploy it in an actual location, test it out for a few months, see the results, do a comparison, what we call as a tabletop exercise, which is comparison of results from the new model versus how we would have planned based on the old model, and then look at actual results and see if the model performed well or not. And in this particular case, of course, we didn't have to do a lot of tweaking, but the reality is in most cases, we'll have to do some tweaking, some adjusting, and that becomes an ongoing process, right? Because we have a base model which has a certain level of accuracy, which may be good enough to be deployed, but then we can now get more data points to kind of optimize it and tweak it. But we would not deploy a model if we don't see the desired outcomes from the get-go. Does that answer your question?
My name is Matt Harmon, Department of Homeland Security. I'm going to ask you the macro question, which could be a huge answer, but looking for small. How can the government help? So specifically, I'm thinking in terms of like data sets and that sort of stuff from FEMA. How can we plug in? Where are the holes? Like I said, big question.
Yeah, so I think the good thing is there's already collaboration happening between, at least from the FEMA and all disaster service organizations. So there's good element of collaboration happening. There's data being shared, things like that. What we have yet to do is try to look at how ML could play a role in all of that thing. And that's also, if you look at just disaster response in general, there's a lot of disruption happening in different areas. There's some disruption happening in Silicon Valley in this area as well. There are organizations who are doing disruption in just disaster response type things. And what's not happened is collaboration across all of these places to have a more coordinated effort of how can we solve these things. So our hope in the future is we're going to start looking at disaster response and how can we help the community in these areas. And that's where we start working with FEMA. For example, the first use case which we're thinking of right now is can we take pictures during a disaster and be able to do damage assessment. So kind of like what you mentioned, but instead of sending people, what we want to do is we'll drive a car or a vehicle or a boat if the roads don't work, and we'll take pictures of the location, and can we put a model in place which automates the damage assessment. Now the catch is technology is not yet there to be able to do that level of accurate modeling, but we feel maybe we can get a 60% accuracy. And if we can achieve something which is in a microcosm workable, that's when we start collaborating and saying, you know what, now how can we kind of expand this at a much more broader level and work with all the organizations, and all of this should be open source, right? To kind of expose it to make sure that we are collaborating at a macro level.
I mean, one of the things that we've been that we've seen in other areas, and I'll just kind of throw it out there for the team to discuss is to get machine learning models to mature, you need a lot of training data. You have to label a lot of data, and so one of the areas that I think in this domain, where people can come together is people care about these causes. They volunteer and both time and money, with the Red Cross or Nature Conservancy because they care, about that topic. And so I think there's some opportunities to collaborate, where if we're collecting data, whether it's from space or on the ground, to activate the volunteer community to play a role in characterizing that data, which then would allow us to create labels to build better models. We build better models, we'll be able to do more automated assessment. So I think that may be an area that we should explore.
Right. It's really, in a way, limited by imagination, right? I was reading an article where we talk about how a fire can be detected using satellite imagery to about 98% accuracy. So mostly, when a fire occurs, most people get to know about it when somebody calls or there's a social media alert. Think about a world which we could use satellite imagery to be able to detect fires and be able to do a response quickly. So there's some research happening in this space, and that can be done in like few hours. The power of something like this is amazing, right? And it's all about creativity. It's about ML and AI opens up so much opportunities which we would not have thought of before. So a lot of it is also imagination. We are just curtailed by the imagination of what is possible.
Yeah, and I would only add that the Nature Conservancy is never going to get all the expertise we need to do our conservation work. It has to rely on partners from all sectors. We have a long legacy of working with the government and FEMA in particular on the HAZUS tool, where we've done storm surge mapping and creating sea level rise working groups within FEMA, and it really is all hands on deck. So that has to happen.
Scott Towsley with Splunk. In the areas here that you're working, you've got conditions and situations before something happens, and then something happens, and then you've got a response and recovery. And we see lots of examples in other areas where data limitations lead to bias in the outcomes in the models that are used. And I just find myself wondering, are you running into problems with data that is applicable before something happens, as it happens, and after it happens, and how do you avoid coming up with bias in what the modeling tells you because you're trying to stitch across fundamentally different situations?
So at least I can talk from our perspective. We have not yet reached that level where bias is becoming a factor, just because we are in the early stages of using ML and AI. So we're not talking about dealing with a highly complex deep learning type model where biases start becoming a big role, right? The type of issues which we deal with is, I mentioned the damage assessment use case, right? So let's think about data limitation which affects outcomes. If you take a satellite imagery, a satellite image of a house will not tell you how much damage that house has gone through. So how much levels of flood do we have, or is the windows broken, or things like that, right? So the easy use case would have been, hey, you know what? Just let's take satellite imagery before, after, compare, and we can figure out. But only for wildfires that can be an effective model because you know if the house is burnt or not. But for everything else, it doesn't work, and we actually need images from the ground. So that's an example of how data, the right data, is important to solve the right problem. But at least we have not yet reached a level of maturity where bias becomes a problem. I think that comes into play when we start using a lot of deep learning models and we start attacking more complicated use cases. I think as an industry, there's just so much opportunity in just simple machine learning models for most of our use cases.
I mean, one thing we've seen is that we have a lot of geospatial analysts that have relied on open data sets, like OpenStreetMap. And if you assume that all the features that really exist on the ground are in OSM, is a bad assumption. So what we found is that it's really important to establish that geospatial foundation up front. Unless you're going to be analyzing each pixel, unless your model is analyzing each pixel, you need to convert it into information. And so a lot of the work we've been doing is trying to create scalable ways to digitize the key features up front, before the event. and which then gives you a better baseline, so that you can both plan, from a preparedness standpoint, but also be more timely on the response.
Yeah, and I would only add that use cases are going to be inherently biased by, is that Twitter user just tweeting a ton and your flood is always in the same management unit, or is someone going on vacation in the same island chain and you're saying that the economic value of coral reefs is more there. But it's different when you go from a use case to an application and you apply it in an applied science or conservation sense, where it's part of the business, part of a planning framework. That goes from use case to community and key stakeholder engagement, because then they'll say, well, that's wrong. And so people always are going to be part of the ML equation.
I think we have time for one more question. If not,
Any other
then we
questions?
can. All right, then we're going to wrap. I'm going to thank our panelists for participating today. Thank you.